A very good day to all my students. Today's topic that we are going to discuss will be test of divisibility. So let's start today's workout. So what is test of divisibility? So a test of divisibility is actually a method or a way to determine or check whether one number is divisible by another number. Now suppose if you divide 24 by 2, we all know it will be 24 divided by 2 will be 12. But suppose if you have a big number, how to check whether that can be divisible by 2? Divisible in the sense means there will be no remainder. But we are not going to perform any actual division. We are just going to look at the number, just follow certain steps and find out whether that number can be divisible by the divisor or not. Okay, so let's check it out. So the first divisor will be 2. Test of divisibility by 2. A number is divisible by 2 if its last digit, or rather the ones place, is a 0, 2, 4, 6 or 8. That means the last digit ends with a 0, 2, 4, 6 or 8. Or we can simply say it's an even number. So if we look at the tables of 2, we all know that 2 ones are 2, then 2 twos are 4, and then we have 2 threes are 6, 2 fours are 8, 2 fives are 10. So if you look at the ones place, it is either a 2, 4, 6, 8, 0. These numbers, if they are in the ones place, means this number, any number which ends with these digits will be fully divisible by 2. That means there will be no remainder. So let's see some examples. The first number that we have, 2092. In the ones place you have a 2. That means this is an even number and this divisible by 2. So the next number, 14,278. That means in the ones place or the last digit is 8, which is an even number, so it is divisible by 2. That means if you divide it actually, you will see there will be no remainder. Similarly, we have these examples, 61,936, which ends with a 6, is also divisible by 2. If we look at these numbers that are there on the screen, in the ones place we have a 1, 3, 5, 7 and 9. That means these are all odd numbers and these are not divisible by 2. If we look at these numbers, let's move on to the test of divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3, which actually means whatever number you have been given, you just need to add all the digits that are there in the number, and if that number is divisible by 3, the whole number is also divisible by 3. So let's see some examples. Suppose we have a number 49,746, and if we add all the digits of that particular number, that means 4 plus 9 plus 7 plus 4 plus 6, it comes up to 30. Now 30 is divisible by 3, where we get the quotient as 10 and there is no remainder. So if the sum of the digits is divisible by 3, that means 49,746 is also divisible by 3. Let's see one more example, 9,82,571, and we'll see if this number can be divisible by 3 or not. So according to the rule, we add all the digits, and if we can see, the sum of the digits come up to 32, and if we divide 32 by 10, there will be a remainder, which is 2. So if there is a remainder, that means that the sum of the digit is not fully divisible by 3. So the number that you have on the screen, that is 9,82,571, is also not divisible by 3. Now let's go to the divisibility by 4. A number is divisible by 4 if the last two digits form a number that is divisible by 4. So if we look at any number or any multiple, rather tables of 4, there will be no odd number that will be in the tables of 4, or rather we can say the multiples of 4. So what exactly we need to look into? All even numbers, to check whether they are divisible by 4 or not. So we will go by examples. Okay, so let's take the example 9828, and we have to check whether 9828 is divisible by 4 or not. So the last two digit is 28, which is divisible by 4 because we get the quotient 7 without any remainder, which means if 28 is divisible by 4, the whole number, that is 9828, is also divisible by 4. Test of divisibility of 5. A number is divisible by 5 if its last digit or the digit in the ones place is either a 0 or a 5. So if you look at the tables of 5 or the multiples of 5, either it has a 0 or a 5 in its ones place or the last digit. So if we check the examples, if we just look at the examples, 2090 which ends with a 0, or a 5055, or a 62,055, or a 300, or a 10,000, or a 50,055, all these numbers which ends with 0 or 5 are all divisible by 5. That means there will be no remainder left. Now let's see the test of divisibility of 6. A number is divisible by 6 if it is divisible by both 2 and 3. That means either of the divisibility test will not work. It has to be divisible both by 2 and by 3. Then only will it be divisible by 6. So let's see an example. 396132. So if you look at the ones place, we have a 2. That means the whole number is an even number, so it is divisible by 2. That means the test of divisibility of 2 is confirmed. Now let's see the test of divisibility of 3, which means we add or sum up all the digits of that particular number and we get 24. So if we divide 24 by 3, we get the quotient as 8. That means it is completely divisible by 3. So once it is divisible by 2 and by 3, the whole number is divisible by 6. Now let's check the divisibility by 7. Test of divisibility by 7 is a bit different from the rest of the numbers. So what happens is, you need to check the full number and the last digit, that means the digit in the ones place, needs to be doubled, and then whatever the answer you get has to be subtracted from the rest of the numbers. So that is how we can find out the test of divisibility by 7. We'll see the examples first, then only we'll be able to understand what exactly is the test of divisibility of 7. So let's check an example. Let's see an example. We have 2086. So the last digit is 6. If we double the digit, it becomes 12, right? What is the number that is left over? The number that is left over is 208. That means we actually do not take that last digit 6. So 208 minus 12 is 196. Is 196 divisible by 7? Yes. We get the quotient 28, which means that the full number is also divisible by 7. Let's take another number, 19,367. So the last digit is 7. If we double that last digit, it becomes 14, right? Digits that are left, 1936 is left. So if we subtract 1936 by double of that last number, 14, we get 1922. Now 1922 is again a big number. So what to do? Again we repeat the same process. So the last digit of 1922 is 2. We double the digit, we get 4. So 192 minus 4 is 188. Again a big number. So we continue this process till the last digit is 8. 8 twos is 16. Now the remaining digits is 18, and if we subtract 16 from it, we get a remainder 2, which is not divisible by 7. So the whole number, that is 19,367, is not divisible by 7. Let's see one more example for the test of divisibility of 7. 1764. So the last digit is 4. If we double it, we get 8. And then we subtract it from the rest of the number. So the rest of the number is 176. And if we subtract 8, we get 168. Now 168 is again a big number. So if we look at the last digit, it is 8. We double it, we get 16. So rest of the number that is left is 16 minus 16, that is 0. And if it is 0, that means this full number is divisible by 7. That means 1764 is also divisible by 7. So now let's check the divisibility by 8. A number is divisible by 8 if the last 3 digits form a number that is divisible by 8. In the test of divisibility of 4, we had seen that the last 2 numbers, if it is divisible by 4, will be divisible by the whole number is going to be divisible by 4. But over here we are going to check the last 3 digits of that particular number. As an example, if you can see 2,98,864, the last 3 digit is 864. And if we divide 864 by 8, we get a quotient as 108, that means there is no remainder left. So 864 is completely divisible by 8, which means the whole number, that is 2,98,864, is also divisible by 8. So let's take one more example, 49,258. And if we look at the last 3 digits, it's 258. So if we divide 258 by 8, we get a quotient 32, but there will be a remainder 2, which means 258 is not completely divisible by 8. And that's the reason the whole number, that is 49,258, is also not divisible by 8. I hope this is clear. Now the test of divisibility of 9, it's more or less very much same there as that of test of divisibility of 3. Over here also you need to add all the digits and the sum. If it is divisible by 9, that means the whole number is divisible by 9. So let's see an example, and let's say it's 930267. Let's add up the digits, and once we add up the digit, we get 27. Okay, so is 27 divisible by 9? Yes, 27 is of course divisible by 9. We get a remainder 3. That means the whole number is also divisible by 9. It is more or less same as that of the test of divisibility of 3. Test of divisibility of 10. Any number which ends with or has 0 in its ones place is all divisible by 10. That means 10, 20, 30, 40, 50, 100, 120, 300, 340, 750, all should the digit in the ones place or the last digit should be a 0. That means all these numbers are all divisible by 10. Hope you understood today's session. Keep watching my videos. So just wait for the next video to get uploaded. Thank you. Have a nice day.